About the connection of solar PV modules in parallel connection. Okay, let's try to see that in a parallel connection, what is constant? Voltage is constant and the magnitude of current is increased. The magnitude of current is increased. So how to give the connection says you take a solar panel. So this is a solar panel 1, this is a solar panel 2. So you are going to have the solar panel like this, and you are going to have one positive terminal like this, and you are going to have one negative terminal like this. So this is one positive terminal of one panel, this is another positive terminal of the one panel, this is negative terminal of one panel, this is negative terminal of another panel. So how to connect them in parallel? So join positive of one terminal to the positive of the another terminal. Here you are going to get the resultant terminal. So join all the negatives. Okay, then you are going to get here. So what are the ratings of this panel? What is the voltage rating of this panel? Vm. And what is the current it is generating? Im. What is the voltage rating of this panel? Vm. And what is the current it is going to generate? Im. So the current Im is coming to this branch like this, and the same current Im is coming like this. Now we are going to calculate the maximum voltage of the array and the maximum current of the array. So here I am going to apply the nodal analysis. So in order to find the current, what I have to apply? Apply Kirchhoff's current law to find the resultant current. So to this node, what are the entering currents? One is, so what are entering currents, what are leaving currents? So current from the first solar module is Im is entering the node, this I am writing it as Im, and current is coming from this module and current is entering. So entering current is how much? Im. So what are the entering currents? Im plus Im. What are the leaving currents? Ima, where Ima is called the maximum current of the array. So therefore the maximum current of the array is equal to Im plus Im is how much? 2 into Im. And you can see here the voltage at the panel is Vm. The same, what is the voltage at this point? Vm and 0 volts. What is the voltage at this point? Vm 0 volts. What is the resultant voltage of the array? Vm A. Okay. Therefore, the maximum voltage of the array is equal to how much? Vm, which is equal to individual panel. Now we are going to calculate the maximum array voltage. So the maximum power is equal to the maximum power of the array is equal to the maximum voltage of the array scaled with the maximum current of the array. So what is the maximum voltage of the array? You got Vm multiplied with what is the maximum current of the array? You got 2 into Im. So therefore it is nothing but 2 into Vm into Im. So which is nothing but 2 times Pm. So the formula we are going to get the maximum voltage of the array is equal to 2 times the maximum power. So when you connect 2 solar panels in parallel connection, the power is increased how many times? The power is increased how many times? 2 times the power is increased. If we use for example, let's try to calculate how many number of panels to be connected in parallel. In a parallel, what is increased? Current is increased. How to write down the maximum current? The maximum current of the array is equal to number of panels connected in parallel connection multiplied with the current of the individual. See here, what is the maximum current of the array you got? This how much? 2 into Im divided by Vm. Then you are going to get the number of panels to be connected in which connection? Parallel connection. For example, let us take that an example. Let's take that the maximum voltage of the array I require as 10 amperes, but I need to calculate the number of panels in parallel, but the individual current of the panel is how much? 5 amps. Each panel is generating how many amperes? 5 amps, but I require the total current of the array is how much? 10 amps. Therefore 10 divided by 5. 5 ones are, 5 twos are. Then how many panels are connected in parallel? 2 panels. Here, how many panels are connected in parallel? 2 number of panels are connected in parallel. Therefore, power is increased how many times? 2 times. For example, the same connection I am going to draw, and I am going to join the positive and I am going to join the negative. Therefore, how many number of panels I am going to connect in parallel now? 3 number of panels in parallel connection. Therefore, power is also increased how many times? 3 times P maximum. If 4 panels if I use, how many times the power is increased? 4 times. If I use 5 panels, how many times the power is increased? 5 times. So the link is, it is multiplied with the number of panel. The power is multiplied with number of panel. So here what is the multiplication factor you are going to have? Where this n I am going to call it as number of panels connected in which connection? Parallel connection. So the total power is multiplied with number of panels connected in parallel. So the resultant you can write down it as NP multiplied with Vm into Im. So NP is nothing but the number of panels you connected in parallel. If the number of panels is 2, the power is how many times? 2 times P maximum. If the number of panels is 3, the power is 3 times. If the number of panels is 4, how many times the power is increased? 4 times. If the number of panels is 5, how many times the power is increased? 5 times. This is nothing but 5 times Vm Im. So this is how to connect the number of panels in which connection? Parallel connection. In a parallel connection, what is constant? Voltage is constant. Vm is constant. So let us take the Vm is 12 volts. This is a 12 volt system. But what is increased? Im is increased. Okay. If 2 panels are connected in series, automatically current is increased how many times? 2 times. As per that, the power is also increased how many times? 2 times. This is how to connect the solar panels in which connection? Parallel connection.